So friends, let's take our next question, that is question number 4. Now this question belongs to section of modern physics and the chapter would be atoms and nucleus. Now as per the question, radiation coming from transitions of n equals to 2 to n equals to 1 of an hydrogen atom falls on helium ions, that is single positive ions, in n equals to 1 and n equals to 2 states. The possible transition of helium ions as they absorb the energy from radiation is, and we have to choose among the 4 options. The basic ideology would be the hydrogen will be providing energy to helium electrons, and due to that energy the electrons from helium which are lying either on the first orbit or the second will move to a higher transition energy state, Now we have to find that transition, that whether it is happening from one of these options, right? Let's first of all find what is the value of energy which has been released by hydrogen. Starting with the solution. In order to proceed, you should know what is the formula for nth orbit for a particular electron. That would be minus 13.6 Z square by n square electron volt per atom, right? Now, this is the energy for any electron in any given orbit. Since we are talking about hydrogen atom, so for hydrogen we are well aware that is Z would be equal to 1. And since the transition is happening from 2 to 1, so let's find that what is the energy which will be released. Simply, it can be written as delta E would be equal to energy of second orbit minus energy of E1. So, in order to find E1, I will write minus 13.6 divided by 1 square into 1. That would be minus 13.6 electron volts. I am just writing the energy value. And for E2 of hydrogen, I will find by putting same minus 13.6 by 2 square into 1 square. That is, okay, here also you can write square. So 1 square, it would be minus 3.4 electron volt. Now, what is the difference which is being released? So you will say delta E for hydrogen would be minus 10.2 electron volts. Now this is the first equation. This much energy has been released. Now we need to find that this much energy, how it will help the electrons in helium to transit from a lower energy state to a higher energy state. So now talking about helium, when you talk about helium, again we have to find the energy states. So let's talk that what is the energy for first orbit of helium, that is the electrons which are residing in first orbit of helium. That would be minus 13.6 into 2 square divided by 1 square. Because for helium you are well aware that is Z would be equal to 2. Solving this, you will get the energy for first orbit would be minus 54.4 electron volts. Similarly, energy for helium in second orbit would be minus 13.6 electron volts. And if you go down further, the energy for helium in third orbit would be minus 6.044 electron volts approximately. And energy for helium for fourth orbit would be minus 3.4 electron volt. Now when you see the differences, either the electrons of the first orbit or the second orbit can absorb that 10.2 electron volt and move up to higher energy state. So it's very evident that the difference between these two is 10.2 electron volts, right? So the transition will be probably between the second and the fourth. So electrons will move from second orbit to fourth orbit. Let's see which is the best suited option here. Among the 4 options given here, option number 1 would be the right answer, right? Let's move on to our next question. Now next question, that is question number 5. The question belongs to section mechanics of chapter fluids. Here water from a pipe is coming out at a rate of 100 liters per minute, right? Now if the radius of pipe is 5 centimeter, the Reynolds number for the flow is of order of, we have to find the Reynolds number, and what it is rho Vd divided by eta. Rho would be the density of fluid, V would be the velocity of fluid, D would be the diameter of the vessel, and eta would be the coefficient of viscosity. Now coefficient of viscosity is already given to us, that is 1 millipascals second, and the density of water is obviously 1000 kg per meter cube. So let's start with the solution. In order to find the Reynolds number is represented by Re, which would be rho V diameter divided by eta. We know the density, we know the diameter, we know the coefficient of viscosity, but the velocity of flow of fluid is not known to us. Instead, what is given to us is Q, that is equals to area into velocity, that would be 100 liters. So I have to convert liters into meter cube per minute, so I'll convert it to 60 seconds. So I have converted this into standard SI form, meter cube per second. On solving this, the area would be pi into 5 into 10 to power minus 2 whole square into V, and this would be equals to 1 upon 6 into 10 to power minus 2, right? So I have to find the value of V here. What would be the value of V? If you find, would be 0.2122 meter per second. Now for Reynolds number, it should be rho V diameter divided by coefficient of viscosity. The density would be 1000 kg per meter cube. Velocity we have just found is 0.2122 into the diameter would be, radius was 5 centimeter, diameter would be 10 centimeter. So that would be 10 to power minus 1 meter divided by the viscosity, which is 1 into 10 to power minus 3, since it is 1 millipascal second. So on solving this, you will get Reynolds number would be equal to 2.122 into 10 to power 4, right? Let's see which is the best suited option here. Among the 4 options given to us, option number 2 would be the right answer, right? Let's move on to our next question. Now the question you see here belongs to section of optics. Here in the figure, optical fiber, the optical fiber is being given here. Let's see, this is the optical fiber which is visible. It's of length of 2 meters and the diameter would be 20 micrometer. So let's mark it here, this is 20 micrometers, right? And the length hole would be, let's say this would be 2 meters till if it is extending here. Now if a ray of light which is incident at 40 degree from air inside this refractive index, which is given to be 1.31. So we have to find what is the number of reflections which is performed here. It's very easy. If I find, let's drop a perpendicular from here to here. If I find this, the value of x, then for this x, one reflection was there. I will simply divide this 2 meter by this x, I'll get the number of reflections. That is, for every x distance, one reflection will be there. This would be x, this would be x, this would be x. Why so? Because here there is complete TIR, that is total internal reflection. So it's perfect symmetry every time. Now in order to find x, I need to find theta. How to find that? Simply, if the refractive index here of the medium is given to us, we can easily find that by Snell's law. So the refractive index of medium is 1.31. For air we take it as 1. So on solving this, you will get, let's start with the solution. What we need to find is x. How we can find? In order to find the value of x, we need to find the value of theta 2. Right? So by Snell's law, I will say mu a into sine of 40 would be equal to mu m into sine of theta 2. Right? Now mu a would be 1, sine of 40 is 0.64 as it is given in the question itself. What is the refractive index of medium? It is 1.31 into sine of theta 2. Now from here you will write sine of theta 2 would be equal to 0.64 by 1.31. If you have a proper calculation, you will find that this is theta 2. So theta 2 is nearly equal to 30 degree, right? This is the first observation. Now from the triangle I have drawn for you here, this is the right angle triangle. This is the value of D, that is the diameter. If I have this diameter that is perpendicular, this is base, tan theta 2 can be written as perpendicular by base. So I will write tan of theta 2 would be equal to D by X, that is equals to 20 into 10 to power minus 6 divided by X. And what is the value of tan 30? That is, yes, will be equal to 1 by root 3, right? So from here you will get X is equals to 2 root 3 into 10 to power minus 5 meters, right? Now what we have to do, the number of reflections we have to find, and it would be simply solving number of reflections n would be equal to length divided by x, that is 2 divided by 2 root 3 into 10 to power minus 5. Solving this would be nearly equal to 57,000. It would be more than that, right? So let's see which is the best suited option here. From here you will find the option number 4 is the best suited option to this question. I hope you have understood this question very well. Now let's move on to our next question, that is question number 7.